The goal of this presentation is to share lessons learned from developing an AI-driven test bench solution that delivers real business value. This solution framework leverages advanced AI and data analytics capabilities that can help organizations use AI to drive better business outcomes. I'll discuss the key features and benefits of this framework and highlight how it enables effective AI in situations that require specific data and knowledge that doesn't exist in large language models. The real goal of AI in business is to solve genuine high-impact challenges, not showcase novelty. And the real measure of success is this. Does the AI solve a business problem? Does it make someone's job easier, faster, or smarter? Many AI initiatives fail because what looks impressive in a demo actually means very little in a specific business context. This is because LLMs only seem intelligent. They're like a person who understands the talking points of a subject and puts them together reasonably well, but is unable to use this knowledge to generate insights based on a specific situation. The key is to craft AI solutions in a way that delivers meaningful results, not just demos that look like magic. General and vague recommendations to improve training or implement a quality program don't help in situations that require actions and decisions based on specifics, like they do in the test bench example we'll look at in a couple of minutes. Finally, a good AI solution won't look like magic. Once you understand how it works, it isn't a mystery, and it's safe to say that any solution that is can't reliably be deployed and counted on. The key challenges in deploying AI solutions for business value are knowledge gaps, accuracy requirements, and integration complexity. AI models typically lack the specific data they need to generate meaningful insights and decisions that are unique to an operation. This knowledge gap often results in insights with very little value, or worse, hallucinations, and business solutions can't afford to hallucinate. If the solution isn't reliable, it just won't work. However, AI can be done reliably and effectively, but successful implementations require coordination between data engineering, business expertise, and AI engineering. Integrating these domains can be a significant challenge, and overcoming these challenges is critical to realizing the full potential of AI for driving business value. The key components of a good AI solution are a relevant data pipeline, a RAG-enabled knowledge layer, an effective AI model and AI architecture, and deployment at the point of value where the value of AI can be used. A relevant data pipeline provides the AI system with real-time, contextual, and integrated internal knowledge to draw upon. The RAG layer makes this knowledge available to the AI solution, while the right AI models are efficient and focused, use the RAG layer effectively, and deliver relevant AI insight fast and cost-effectively. Finally, building on an AI platform that provides frictionless workflows and integration of the tools you need to develop AI takes away significant complexity, enables you to build, deploy, test, and refine much faster. And now for our manufacturing test bench case. In many manufacturing environments, products go through a series of tests at the end of assembly. When a product fails, test operators often use trial and error to diagnose and fix it, which leads to inefficiencies and inconsistent outcomes. There are several things that make this a real problem. New products, new manufacturing lines, new suppliers, or new employees make this a real and recurring issue. Ironically, when a product fails, it's more likely that it'll fail again, and the more it fails, the more disruptive it is, and it's more likely parts and components will be unnecessarily scrapped in the troubleshooting process. Meanwhile, approaching a critical operation like this is a huge missed opportunity for meaningful, continuous improvement. Capturing test data and turning it into useful information is an obvious way to improve occurrence cost and identify and correct the root causes with the greatest impact. However, without a solution in place to support this goal, the pace and impact is very slow and only happens when issues are huge and obvious and have already had a significant negative impact. Mapping this particular case to the components of a good AI solution I shared earlier, we created a relevant data pipeline by delivering test data from LabVIEW to the data layer and used that data to create troubleshooting data which we loaded into the RAG layer to provide the specific intelligence, used as a tool of the LLM to deliver accurate troubleshooting guidance fast and cost effectively. Within LabVIEW in real time, where operators use the AI to execute rework fast and efficiently. This results in greater throughput, less rework, less scrap, less testing, and more capacity. Here's a look how the solution looks from a technical perspective. The architecture document shows the data and workflow. The recommendation engine works within LabVIEW. Real-time recommendations are returned to the test operator based on test failures sent directly to the AI. The recommendations are retrieved from a database that's engineered from the raw test data sent directly from the individual tests. This also supports reporting and analytics on testing and AI-assisted analytics that return insights to cell managers or manufacturing engineers. Results of this application include improved first-pass test yield by over 20%, meaning more products passing testing on the first try, while all retests were reduced by 50%, resulting in significant reduction in the cost of rework and 30% greater manufacturing capacity. Overall, the AI-powered solution is estimated to deliver a remarkable 284% return on investment over 5 years. And that doesn't include any estimate for throughput or capacity. RAG, or Retrieval-Augmented Generation, is a critical part of this solution. LLMs alone are powerful, but are only general intelligence. They're prone to hallucination, and when you look closely, they provide generic responses with limited value. RAG architecture connects an LLM to specific data, knowledge, and intelligence, enabling it to provide context-aware, verified, and specific responses. With RAG, the system retrieves real information curated for the task, leading to accuracy and trust in the responses. RAG allows us to leverage the strengths of both LLMs and targeted information retrieval to deliver reliable and tailored solutions for a variety of applications. In this architecture, speed and cost aren't trade-offs, they're features unlocked by RAG. The RAG framework allows us to use lightweight models which are faster and cheaper to deploy, and they're excellent at using specific content and knowledge provided by the RAG-related assets like vector databases. This combination also controls errors and hallucinations, which builds reliability and trust into the solution. The key takeaways from our AI implementation are that specificity, domain expertise, and efficiency are critical for success. Solving specific business problems rather than deploying AI assistance as part of other tools is the most effective way to score wins with AI. Enterprise data is AI's most powerful tool for your company. Use it to deliver RAG AI. Focusing on speed, simplicity, and cost effectiveness as core features, not trade-offs, allows you to deliver more value with your AI solutions. These three principles, specificity, domain expertise, and efficiency, are the keys to unlocking the full potential of AI in your organization.